Hi class, this is Dr. Karsten, and today I am going to be explaining Lesson 7 for Module 5 in Grade 4. Now today I'm going to have a little bit of a longer introduction than I normally do to the lesson, and that is because there are a number of concepts and ideas that you really have to be solid on to move forward with fractions and where we are going. So I want to cover those, and it won't take us too long, but let's get started. So I am sure that you have heard before that 1 is the identity element for multiplication. So what does that mean? That means that if I take a number, say 2, and I multiply it times 1, that 2 is going to stay the same. It's still going to have the same value. It's going to stay 2. Similarly, if I multiply 35 times 1, I'm still going to have 35. It also keeps its identity. It stays the same. Or if I had 2/3 and I multiplied that times 1, 2/3 is going to be my answer. It's going to stay the same. So 2 stays 2, 35 stays 35, and 2/3 stays 2/3. So that's why 1 doesn't really change things. If you multiply by 1, you are not changing the value of the number. Now, let's think about fractions for a second. When I have 2 over 2, or 2 halves, what does that really mean? It means that my whole, so this represents 1 whole, my 1 whole is divided into 2 pieces. We know that because the denominator is 2. What else do I know? I know that I actually have both those pieces. If I have both those pieces, that actually means that I have 1 whole. This entire thing is 1, and I have the whole thing. So really, 2 over 2 is just equal to 1 whole. Think about an apple that's been cut in half. If you have both halves, if I cut this apple in half and I have both halves, that means that I still have 1 whole apple. It's just cut into 2 pieces. Similarly, if I have 4/4, let me do a tape diagram for that. My denominator is 4, so I'm going to make 4 parts. And I have all 4 because my numerator is telling me I have 4/4. I have all 4 of them right here. So if I have 4/4, that's the same thing as saying I have 1 whole. Okay, so now that we know that if you multiply by 1, you aren't changing the value of the number or the fraction. And similarly, now what that means is that if I were to take 2 and multiply it by a fraction that is equal to 1, so let's just take that 2 over 2, I'm still just going to have 2. The value isn't changing. Now, admittedly, that 2 times 2 over 2 is going to become 4 over 2, so I have a fraction greater than 1, but it is not actually changing the value, because if I take a look at this, remember my original fraction, so now let's say that I have 2 wholes, so this represents 1, and this is another one, but they've been each cut in half, and I have all of them. So you see, this represents 1, it's cut into 2 pieces, or it's separated or divided into 2 equal pieces, but I have 4 of them now, and you can see that that gives me 2 wholes. And I can just put them next to each other like this. So this is 1, and I'm just going to bracket this off to show you this is another 1. So this is showing you that as long as I multiply by a fraction that is equal to 1, so 2 over 2 is equal to 1, 4 over 4 is equal to 1, 100 over 100 is equal to 1, you're not changing the actual value of your number or your fraction. Now, why would we want to do this? That's a really great question, and there are lots and lots of reasons. Let's say I have a candy bar, and I want to break that candy bar up into smaller pieces so I can share it with more friends. That would be a really great reason to want to change the number of pieces that my whole thing has been divided up into or has been split into. Or maybe you want to add fractions. So let's say I wanted to be able to add 2/3 plus 1/4. Well, we know that we can't add unlike denominators. We can multiply them, but we can't just go and add them. The denominators have to be the same. So that might be another place that I want that, but that is taking a peek into the future. For now, let's focus on wanting to decompose or split apart things into smaller pieces because maybe we want to share them with more friends. So those are the concepts that we really have to understand before we move forward in this lesson. Now, another thing that I really want to go over with you is how today's lesson is going to be slightly different from yesterday's lesson. Now, in yesterday's lesson, let's say that I had 1/2. So I like going back to the 1/2. It's a nice simple number to work with. So let me start at the top of my page. So let me model that. So I'm going to draw myself a nice diagram here. And I'm going to go ahead and cut that in half because I'm trying to model 1/2. And since my denominator is 2, I have 2 pieces to make up the whole. And then I'm going to go ahead and I'm going to shade in one of those. Now I do need to put a bracket on top to represent what's going on. So I'm going to go ahead and bracket off that this is 1/2. And now let's say that, that's that candy bar that I want to share with my friends, and I want to turn that into 6 because there are going to be 6 of us sharing the candy bar. Yesterday what we did was we kind of did this little thing that I did over here where I said, well, how do I turn that 2 into 6? What would I have to multiply it by to turn it into 6? Remember we said 2 times a number is equal to 6. Kind of going off screen there. There we go. And the other thing we said was that I could also do the inverse and say 6 divided by 2 is going to give me that number that I'm looking for. They're the same number. And we said, okay, well, that's going to be 3. 3, and here, it's times 3. Or I could say 6 divided by 3 gives me 2. And then we said, well, I would do the same thing on top. And that would give me 3. And I'm going to model that over here really quick for us. So since I have 3, I know that I have to split each one of these into 3 pieces. So I put 2 lines across. Now I have my 6th. 1, 2, 3, 4, 5, 6. So my new denominator is 6. And my new numerator is 1, 2, 3 because that's what's shaded or what I have. Okay, so here's where we're going to make a shift in today's lesson. Instead of writing it like this, we're going to write it in a new way. We want to be able to really show that we are multiplying by 3 over 3. And again, we know that 3 over 3 is just equal to 1. So I'm not really changing anything. I didn't change what's shaded. I didn't add or subtract anything to that. It was still the same amount of this entire thing, this whole thing that's shaded. So when we multiply times 1, nothing changes, but now we're going to show it differently. So instead of writing it like this, we're going to go and we're going to say that 1/2 is equal, we're going to end up still in the same place, 3/6. But instead we're going to do something in the middle here, which is we're going to say that to turn this 1/2 into 3/6, I need to multiply it times 3/3. And that's really what we have here, is I'm multiplying the top by 3 and the bottom by 3. So I'm going to go ahead and show what I did. So I'm going to rewrite my 1/2, and now I'm going to multiply it by 3 on the top and the bottom. And now you can see, really I'm just multiplying by 1. So I'm not really changing the value of it. I'm just changing how many pieces I have, how many pieces it is cut up into. So that is how things are going to change today, is that instead of doing this little arrow here like this, we're going to show it as an equation. We're going to actually put it right here in the middle. So remember, you're going to have your 1/2, you're going to show you're multiplying it times 3 on the top and the bottom, numerator and denominator. So you're going to rewrite that 1/2. Don't forget that. Okay, so that's the difference. Oops. So let's jump right into the problem set. Now, I was kind of thinking, at this point, if you've watched any of my videos before, that I tend to skip the first ones if they already have stuff divided for us. But I think today I'm going to work with one of them, and I'm going to give it a shot, because I think it's not as bad, especially now that you're more comfortable doing this type of problem. So, here what we're doing is it says the shaded unit fractions have been decomposed into smaller units, and that's what those dotted lines are. Express the equivalent fractions in a number sentence using multiplication. The first one has been done for you. So let's go ahead and let's take a look at this one. And let's see if we can figure out what they originally did. This looks kind of familiar. Does this look like what we just did? So if I go ahead and I bracket this off, and I want to show originally without the dotted lines what was there. So pretend these lines aren't there. I can see that originally this whole was cut up into two pieces. It was divided into two parts. So I know that the denominator has to be 2, and I wish this wasn't so small, sorry. And then the numerator would have been that one of these two parts was shaded in. Okay, so now what I can see is that they split this up twice. They made it into 1, 2, 3 pieces, 1, 2, 3 pieces on both of these. And again, I'm going to go ahead and write 1/2 is equal to, and let's go ahead and see, we have 1, 2, 3, 4, 5, 6 pieces. So my new denominator is 6, and my new numerator, the number that is shaded, is 1, 2, 3. So now we have to say, well, how did I turn this 1/2 into 3/6? And what we did was we multiplied by 3. And if you wanted to right now, you could kind of still do that little trick that we do and say, well, how do I get over there? What am I doing? And again, I could say, well, 2 times a number is equal to 6, or 6 divided by 2 is equal to that number. Again, we get our 3's. So now I know I'm multiplying both the top and the bottom by 3. I know I'm multiplying them both by 3 because 3 over 3 is equal to 1. Remember that. So I didn't change the value. Okay, let's jump into one of the problem 2 questions for you, because I feel like we've done that one a couple times now. So let's take a look at what's going on in problem 2. So this is really, really similar. We're going to basically be doing the same thing. So it says decompose the shaded fractions into smaller units using the area models. Express the equivalent fractions in a number sentence using multiplication. So let's go ahead first and figure out what is our original fraction here. And I'm going to bracket that off for us. So if I take a look, my denominator is going to be the number of parts or pieces that the whole thing has been split into, divided into. And here I see that there's 1, 2, 3, 4 pieces. So that's my denominator. And then my numerator is the number of pieces I had, and the way that's represented is by shading them. So here I have 1 piece. I'm going to write that here. So we have 1/4. So now we get to pick what we want to turn this into. So how about, let's go big, let's go bold. Let's turn that 1/4 into 16ths. So I'm going to go ahead and write 1/4 is going to be equal to, I'm going to go ahead and set this up, 16ths. So now I'm going to set up also here 1/4 times, and I have to figure out 4 times what number gets me to 16. How am I going to do that? So I'm going to figure out how I do that. And again, if I'm doing that, another thing that I can do is I can kind of on the side here think to myself, 4 times what number is 16, or 16 divided by 4 gives me what number? And you should be able to figure out that that other number is 4. So I need to split each of these up into 4 pieces. I'm going to have to draw 3 lines to make 4 pieces. So that's going to be nice and easy. So you can see I split them up, I cut them up. So now let's just double check that I did this correctly and see if I have 16 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I do. And let's see how many pieces I get. 1, 2, 3, 4. So my numerator is going to be 4. So the number that we figured out we were multiplying by is 4. And I can write that in both parts, in both places here. And again, multiplying by 4 over 4 is just saying that I'm multiplying by 1. And I know I keep writing that because I really want to drive that point home. So this is really what we're looking for right now in this problem. So now I've done 3 of them for you. I'm feeling pretty good that you can probably do B. So just remember first that you need to bracket off this and figure out what was your original equation, or sorry, original fraction. Sorry about that. And then you are going to get to decompose it into smaller units, smaller pieces. So decompose, pull apart, and then I want you to continue working on this. Now, I do want to show you problem 3 because I want to get you started on it with the first part of it. It's a little bit different. So in problem 3, it says draw 3 different area models to represent 1/3 by shading. So basically, you are going to do this 3 times. Let's just do that first part. Don't even worry about what the rest of it says. But you need to start by drawing one of these models. So here's my whole, and then I'm going to split it into thirds. I'm going to divide it into 3 equal parts to make thirds. So remember thirds. There we go. So then I have to shade one of them. So again, since my denominator is 3, I split it into 3 pieces. My numerator is 1. I'm going to shade in 1. So we're still working with unit fractions, or we're back to working with unit fractions today. We keep going back and forth. So I've shaded it in. So that's the first part. You're going to do this 3 times. That's how you're going to start each one of these questions in B. So A, B, and C. In question number 3, problem 3, you're going to start it off exactly the same. Now it says decompose the shaded fraction into sixths, then B is ninths, and C is 12ths. So if I need to put it into sixths, I need to think, how am I going to do that? So let me write down what we've been doing. I'm turning my 1/3 into sixths. And again, on the side, if you don't immediately see that it's going to be what it's going to be, that you're multiplying by to turn 3 into 6, you can always do it on the side. 3 times what number gives me 6? A little off screen, hold on. Or again, 6 divided by 3 gives me that number that I'm looking for, and you should find 2. And a lot of you will just see it right away, and you don't have to do this on the side. So I'm going to put that 2 in right here. But again, because I want to really keep it as just I'm multiplying by 1, and 2 over 2 is going to be that 1 that I'm looking for. I'm going to put a 2 up here. And now I can finish this out by going 1 times 2 is 2. Well, let's see what happens. I've now figured out that I have to split each one of these into 2 pieces, or into halves, in order to make 6s. 3 times 2 is 6. So I'm going to go ahead and do that. Remember, the number that we get here or here is the number of pieces that we have to make here out of each one of these thirds. So I'm going to go ahead, and this time I'm going to go ahead and draw a dotted line. And now what you can see is that I sure do have 1, 2, 3, 4, 5, 6 pieces, and 2 of them are shaded. So you're going to do the other 2. Remember, for B you're doing ninths, and for C you're doing 12ths. So that'll be part of your homework. So I hope that this made a lot of sense, and I hope that you really understand why this is a useful thing to know how to do. I will see you all tomorrow morning in our Google Classroom. Have a great night.